if I want to solve this system, I look at which letter to cancel first to make my fourth and fifth equation, and I would cancel my z's because those look the easiest. I'm going to call this my first, my second, and my third. So in order to do this, I'm first going to take, looking at these, my first and my second. And for my first equation, you got to multiply your first equation so the z's cancel. So I'm going to start off with my second equation, which is 6x plus 4y plus 2z equals 2. And I got to multiply this by something so that the z's cancel. So I basically got to change this to a 2z, my first equation. In order to change this to a negative 2z, you need to multiply by 2. When you do that, you get 18x, and then 2 times 5 is 10y, and then this times this is negative the 2z we wanted, and 2 times negative 11 is negative 22. Now you might have done a different route. That could be a problem when you try to watch somebody, because they might have done it a different way, because there's multiple ways to solve this. This is the one I chose. So those are gone. So my fourth equation, or my next equation I create, when I combine these, add straight down, you get 24x. When you add straight down, you get 14y. When you add straight down, you get negative 20. That is my fourth equation. Now, to make my fifth equation, I'm going to have to take the third equation, which is 2x minus 2y plus 4z equals 4. This is my third equation, and I got to combine my third equation with either the second or the first. Now, to combine it with the first, I have to multiply this by 4 to cancel. To combine it with the second, I have to multiply it by negative 2 to cancel. Negative 2 is smaller, so I'm going to do the second equation, and I am going to multiply this so it cancels by a negative 2. So when I multiply the second equation by negative 2, I get negative 12x. Negative 2 times this would be negative 8y. That would be negative 4z, which will cancel right there. And negative 2 times 2, which is negative 4. When I add straight down, the z's are gone, leaving me negative 10x minus 10y. This is gone, and this gives me 0. And I'm going to call this my fifth equation. So my fourth and fifth equation. My next step is to solve my fourth and fifth equations for the variables that are left. Now in order to solve this, the first thing you're going to do is get a common number between the 24, the 10, the 14, and the 10. Now there is a shortcut you could do, but most people struggle with it. Do you guys understand, since this is an equation, I could divide the whole thing by 2 and reduce my numbers? Could I divide this whole thing by 10 and make these very small numbers? You could, but that's going to confuse and mess most of you up. So I wouldn't recommend that for most of you unless you understand what I'm saying. But you could divide both these to reduce the numbers in them, because everything here has a 2 involved, everything here has a 10 involved, and even though 0 doesn't, 0 can divide by anything. Anyway, besides that, the goal then is to, how do we cancel out a variable? Well, 14 and 10 seem like the smaller numbers than 24 and 10. So what I'm going to do is I'm simply going to multiply this one. I'm going to try to cancel the y's. So simply I'm going to multiply this top one by 10 and the bottom one by 14. Because if I multiply this by 14 and this by 10, this would be 140 and 140, they would cancel. So my fourth equation would now be 240x plus 140y equals negative 200. And when I multiply 140 in for my fifth equation, when I multiply 14 in, that'd be a negative 140x. This would be a negative 140y. And this would still be 0. 0 times 14 is 0. I'm going to solve this. Again, my whole goal was so I can, using these two green equations, so I could cancel a variable. Bam, that's gone. This leaves me 100x equals negative 200. And when you divide by 100, you get x equals negative 2. So x, y, z. Negative 2 is my first piece. Okay, bigger numbers than usual. I got x. How do I find y? Well, you take this number and plug it into one of these two. Well, wouldn't this have smaller numbers? So I would take after the fifth. So I'm going to go to the fifth equation. I'm simply going to take the negative 10x minus 10y equals 0. I'm going to take this negative 2, plug it right there. I'm taking the negative 2, plug it right here. That gives me 20 minus 10y equals 0. When you minus the 20 over, negative 10y equals negative 20. And when you divide by negative 10, you get y equals 2. There's another piece. Now, so all we did basically is solve my fourth and fifth. Solving my fourth and fifth, I did right here, got my x, plugged it back into, it looks like my fifth, found my y. How do you find z? Well, you take x and y and plug it into one of these three. It does not matter which one. You just got to choose the one that looks easiest to you. I'm going to choose the third. So right over here, I'm going to choose my third equation. My third equation is 2x minus 2y plus 4z equals 4. My x, again, was negative 2. My y was 2. And I'm going to solve for z. Okay, I'm taking this third equation right here. So I got negative 4 minus 4 plus 4z equals 4. A lot of 4s. Hopefully that's negative 8. Just be careful. This question has a lot of, you have to be careful. If you're not careful, this is terrible. Add the 8 over. Divide by 4. Z ends up being 3. There is your answer. And almost all my answers seem to be integers, meaning whole, positive, or negative numbers. If they're not, you messed up somewhere, go back up, find your mistake. You got to learn to be very careful on these kind of questions.